Today we're going to start sketching graphs with more characteristics. So we've discussed end behavior, and we've also discussed briefly y-intercepts and some various characteristics, and now we're going to put it together. So let's look at an example. We can call our function y, f of x, g of x, whatever the name of the function is. That's the name of the function that we're going to continue to use. So let's look at a function p of x equals 4 times x minus 2 times x plus 3 times x minus 1/2. Now, some of the characteristics of this polynomial is that this is a third degree polynomial. And again, the way that I know that this is a third degree is by taking the first factor that's out front and multiplying it times the factor of x on each of the polynomials. So currently, I have what's called a leading term. If I were to multiply this polynomial out, my leading term would be 4x cubed. So some characteristics of this graph is that I have a degree of 3, and I have a leading coefficient of 4. Now, with those pieces of information, I can determine the end behavior of my graph. So remember, when we're talking about our end behavior, we're talking about what happens on the left and the right-hand side of the graph. So when we're discussing the left-hand side, which I'll abbreviate LHS, we're talking about as x approaches negative infinity. So as x approaches negative infinity, what is happening to the y values? Well, because I have a third degree with a leading coefficient of 4, on the left-hand side I have arrows that are moving downward. And if the arrow is moving downward, that means the y values are going to get more and more negative, and we say that is approaching negative infinity. On the right-hand side of the graph, which we will abbreviate today as RHS, again, leading coefficient of 4 and a degree of 3 means that the arrow is moving in an upward direction. We say as x is approaching infinity, which is the right-hand side of the graph, the polynomial function is increasing, which means that it is approaching positive infinity. And again, this allows us to know what the ends of our graph are doing. Now we need some other pieces of information to sketch our graph. One of the other pieces we need is the y-intercept. Now the y-intercept is what happens when we plug in a 0 for x and find the place on the y-axis where the graph crosses. And so I'm going to just put a 0 in each of the places where I have an x. And I'm going to start simplifying down this polynomial. So 4 times negative 2 times a positive 3 times a negative 1/2. And now the negatives are going to cancel out, so I'm going to get a positive value for this y-intercept. And if I look at what's happening over here, 4 times 2 is 8. 8 times 3 is 24. So 24 times 1/2 is 12. So what happens is I have a y-intercept where x equals 0 and y equals positive 12. And I'm going to want to use that information to help myself sketch this graph. Now the last piece of information that I would like to know is how am I going to tell what the graph is doing? What I'm going to do is I'm going to use a number line. It's going to be a little wannabe x-axis. And so with my number line, if I think about where the y-axis is going to cross, kind of right here, this is when x equals 0. And so I also need to know what my x-intercepts are, or my zeros of the graph. So my x-intercepts, these are my zeros. We've talked about zeros a lot. And so what I need is I need to look at all of the places where my polynomial is equal to 0. Now the factor of 4, if I set that equal to 0 and try to solve, I'm not going to get a 0. There is no place for me to solve. So I don't have to worry about when 4 is equal to 0 because that's not possible. I do have to worry about where my other values, my other binomials, however, are equal to 0. Right. So right now what I have is I have x equals 2, negative 3, and positive 1/2. And so these are actually my x-intercepts. And if I write those as ordered pairs, I get the coordinates 2, 0, negative 3, 0, and 1/2, 0. And what I want to do is I want to put those on my graph to get a general idea about what's happening. And so if I put those in order, and I start just kind of thinking about my graph here, this is going to be negative 3. And then I've got my 2. And then I also have this 1/2, which is right about here. Now what we can do is we can make a sign chart. All right? And so what a sign chart does is it tells us if the graph, as I'm sketching through these intercepts, is it going to be above the x-axis or below. Now any values that are above the x-axis, right, will have a y value that's positive. Because if I'm going to plot a point, y is 1, 2, 3, and it's going to keep going in a positive direction for all of the areas above. I also have values that are below the x-axis, and that will be all of the y values where y's are negative. So when I'm checking a sign chart, what I want to do is I want to look at values that are in the zones in between my intercepts and think about what is happening on either side of those. And so we're going to be kind of thinking about sectioning off each of the zones where the x-intercepts are. Now I'm making these little dotted lines, but these are not asymptotes. What they are is just so you can see the sections of the graph. So if I pick a test value somewhere in this area, right, whatever happens to that test point happens to every point on my graph. And so what I'm going to do is I'm going to pick something like x equals negative 4, and I'm going to test that value. Right? What I'm going to do is I'm testing that value actually in my polynomial to see if I evaluate this polynomial for negative 4, what is the value of my y value? Is the output value positive or negative? And that's what I'm going to do. I'm going to check p of 4. Oh, sorry, p of negative 4. Make sure we use the right sign. So I need to check p of negative 4. And I just want to know, is the sign positive or negative? And now I don't care about the actual number, just the sign. So the number 4 on the outside I need to use, which is positive. And what I'm going to do is I'm really plugging in negative 4, just like I did when I was plugging in 0 to find the y-intercept, to figure out what is happening with this graph. Now, I just, like I said, need to know the sign. So the value of 4 is positive, times minus 4 times minus 2, the value of what's inside that binomial is negative. It's negative 6, but I don't really need the number, I just need the sign. Minus 4 plus 3 is also a negative, and minus 4 minus a half is negative. And so if I think about the value of all of the signs, I have opposite, or I have odd number of negatives, which means the value of negative 4 y value is going to be a negative number. Again, it doesn't matter to me what the actual number is, just that it's negative. And if it's negative, that means that I'm below the x-axis. So that means that I'm down here in this zone. And if I think about what's happening with my end behavior, on the left-hand side of the graph, my arrows are going downward, which is another way for me to check that, yes, I am in the right zone. And so I know that my graph is going to kind of come through here, but I don't know, is it going to bounce off or is it going to go through? So again, I can pick a number. It doesn't matter which number you pick. I'm going to pick -1, but I can pick any number in between this area. All right, going from -3 to +1/2, I can pick anything I want in there to check. So I'm going to pick P of -1. All right. And again, I'm going to do the same idea. The number 4 stays where it's at, and I have -1, -2, -1 plus 3, and -1 minus 1/2. And so value-wise, again, the 4 is always going to stay positive. Inside this first binomial, -1 minus 2 is a negative number. -1 plus 3 is a positive number. And -1 minus 1/2 is another negative number. And now I have an even number of negatives, which means the value will be positive if I plugged all that in my calculator. So I'm up here in this zone. So what that's telling me is that if the graph is starting from the left, it has to go up through the -3 and stay up here in this zone before it goes down to the 1/2. And now I don't have much space to start checking, or very many numbers right now that I can think of to check between 1/2 and 2. So I'm going to use 1. Okay, we're going to do the same thing. So P of 1. So 1 minus 2. I'm just going to start plugging 1 in to all of those polynomials again. And so I have 4, which is positive. 1 minus 2 is negative. 1 plus 3 is positive. And 1 minus 1/2 is also positive. And so overall, odd number of negatives means this is going to be a negative value, which means I'm going to cross down into that zone that's below the x-axis. And now I have one more I need to check. Now I'm pretty sure it's going to be up here in the positive zone because the right-hand side of the graph is going up like this. And so I'm going to check the number 3 just to confirm. But again, 4 times 3 minus 2 times 3 plus 3 times 3 minus 1/2. Now again, the value positive, positive. All of these look like they're going to be positive values. Not sure where one came from. They're all positives, which is a good thing, because I'm pretty sure I needed to be up here in that zone based off of end behavior. And so what's happening now is I have a general sketch of what this graph should look like based off of my sign chart. So it needs to kind of come through here, go through that 0 and stay up in this zone. And then it's going to need to somehow drop down, turn and go back up, and then at some point kind of come this way. All right, so that's the general behavior of what this graph is going to do. Now again, we can check on Desmos, but what I'm going to do is I'm going to use some information with my end behavior, my y-intercept, my zeros, and this sign chart, and try to make an actual more accurate graph. Now to do that, I am going to need to make an XY axis. So why don't you get out something that you can use to make an axis. Let me see if I can find something. Nope, can't really find anything. Alright, so I'm going to use a straight edge. So let's just give ourselves a general straight edge here. And now I do need my graph to be able to go up to a positive 12. And so I'm going to keep most of my space in the upper part of my graph. Right. So let's see, 1, 2, 3, 4, 5, 6. I'm going to label these, each line. I think I'm going to label those by 2s. So 2, 4, 6, 8, 10, 12. All right. And my y-axis is going to have different increments than my x-axis. I don't have enough space to make them exactly the same. And so that's what I'm going to do. I'm going to try to make them a little bit different increments. Okay. So now what I do know is I know that based off of my x-intercepts, I need an intercept at -3. I need an intercept here at 1/2 and another intercept at 2. I also know that I have a y-intercept of positive 12. And so what we're going to do now is we're going to try to sketch our graph as much as we can through those points. And so this is going to be a little bit of the tough part, because I don't know exactly how low this graph is going to go. But I do need it to go through those zeros and also through that y-intercept. And so it's a very, basic sketch. It's not going to be 100%, but it's going to be a little bit more accurate in terms of how high up this graph goes. But again, these zones in here, not really sure. I mean, it could go up here and turn and then go back down, and it could go down super low. I'm not exactly entirely sure. So let's look at our Desmos real quick just to check it out. So let me see. So that's a little better. So y equals, we had a 4 times an x minus 2 times an x plus 3, and then times an x minus a half. And I'm just going to type in 0.5 for my half. Right. And so let's see. Yeah, it stretches way up there. So you can see this is a crazy looking graph. It crosses over here at 12. All right, but in reality, it goes way, way up high, somewhere around the 40s, and then down again. So it's a really tight graph. All right, and so that's going to happen. All right, the main issue that we want to deal with is just the general sketch. All right, and so what you're going to be focusing on today is some general sketching. Right? And so this is what your graphs are going to need to look like. All right, you're going to be asked to find the leading term and identify the degree and leading coefficient. All right, so you're going to describe your end behavior. You're going to find the y-intercept, and then you're going to find your zeros. Right? And then you're going to make a sign chart like this, and we're going to do the same process. Right? I'd like for you to get a general type sketch, again, based off of your understanding of how the sketch works, but utilizing the y-intercept as well, so that way you can see that it goes up a lot higher than just that general sketch. Right?